All right, here's question number 28. This is one of the simpler ones. The graph of the derivative is shown. Which of the following intervals is the function decreasing if this is the graph of the derivative? So when the derivative is below, it's decreasing. When the derivative is above, it's increasing. So where are the intervals where it's decreasing? So it's pretty obvious, you can tell, from 0 to 2, it's decreasing. And from 4 to 6, it's decreasing. And that's it. So the correct answer here is E. Number 29. There's something right here. See if we can sell this down. My light went off here. All right, here we go. The graph of the derivative is shown. Which of the following could be the graph of the actual function? So one thing I'm looking for here before I start looking at it is between -2 and +2, it's increasing. So I know it's decreasing and then increasing and then decreasing because it's below, above, and then below. If I was looking at the second derivative, then I'm looking at the turning point. So at 0, we have a point of inflection. And it's increasing. So it's concave up and then concave down. So this is what I'm looking for. So I want you to turn the page and see, can you find the graph that's decreasing, then increasing, and then decreasing? And there would be a minimum at -2 and a maximum at +2. I'm also looking for concavity. It's concaved up to 0, so it smiles up to 0, and then it frowns after 0. All right, let's see if we can find the answer. All right, so why is this the right match for it? I don't like that the camera keeps blinking on and off. I'm trying to prevent it from flashing. All right, so E is right. See if I can do something quick. See if that prevents it. Turn on a little more light. All right, so how does it match? First of all, it's concave up and then concave down. It decreases, then it increases, then it decreases. It completely matches it. E is the one that matches in terms of what the graph would look like. Number 30. If f is a continuous function on the closed interval, which of the following must be true if it's continuous? And so I want you to look at each option. If it's continuous, there is a number c so that f at c equals 0 if it's continuous. No. So a function doesn't have to equal 0 on there if it's continuous. There is a number c in the open interval so that this happens between a and b. Well, a doesn't have to be the smallest number and b the largest number. The correct answer is going to be right here. So there is a number c in the closed interval such that there's some number that's greater than another number for all x from a to b. This one's more of a conceptual kind of question in terms of understanding continuity. Number 31. Let f be the function with the first derivative that you see. How many relative extrema does f have on the open interval from -4 to 2? All right, so this is a calculator question, so let me take out the calculator. Sure you can see it. All right, here we go. So you're given the derivative. To find relative extrema, take the derivative and make it equal to 0. Let's start there. So we're solving an equation. I'm going to take the derivative, which is 3. Solve. So first of all, we're solving an equation. So it's parentheses 3 subtract 2x subtract x squared. And then it's sine. And then it's 2x subtract 3. So make sure I typed it in correctly. Equals 0. And then we're going to solve for x. All right, so take the derivative. Make sure I typed it in correctly. And then we have a restriction. We have an interval. So we're going to press Control equals, and then the vertical line. And then we're going to have the skill to put in the interval, which is from -4 to 2. So go -4 to 2. Make sure you go Control equals to find those buttons. All right. So when I solve it on that interval, this is the answer that I get. And now let's see how many answers I get that make it equal to 0. So I have, here, let's see here. I got 1.5, 1, there's 2, there's 3, there's 4, there's 5, and there is 6. Now, if I wanted to, there's another way I could do it. So, if I went and if I graphed it, so if I went tab and I graphed it, let me delete this part. So if I typed it in, see, I want to make sure that it crosses, that it goes from positive to negative or negative to positive. So to make sure that's true, so I'm going to graph it, make sure it's right. And I want to see from negative 4 to 2. So I'm going to press menu and window. And then the window settings, I'm going to go from -4 to 2. And then when I look at each one, does it cross at each one? See how it crosses over the x-axis? So there's 2 right here, 1, 2. There's another one here, that's 3. There's 4. And then there's 5 and 6. 6 times it crosses over. Every time the derivative crosses over the axes, it creates either a maximum or a minimum. So how many relative extrema does it have? And the answer is E. It's 6. So let's make sure we wrote down what we did. So even though we used the calculator, we took the derivative equal to 0, and that means 6 times it crossed the x-axis. All right, number 32. The derivative of the function, and they give you the derivative again, says that which of the following values of x does f, the function, have a maximum? All right, so we're going to do what I just did. So I'm going to graph it and see where it crosses. And for it to be a maximum, it has to be above to below, positive to negative. So we're going to look at that right now. So let's take out our calculator again. I'm going to change this. So I'm going to go back here. I'm going to erase what I had before. And it's going to type it in. So I'm going to type in x cubed subtract 4 sine x squared plus 1. Let's make sure I typed it incorrectly. So x cubed minus 4 sine x squared plus 1. So I want to graph it. Now from negative 2.5, so I'm going to press menu and window again. This time, press number 1. I want to go from negative 2.5 to positive 2.5. And I want to know how many times does it go from positive to negative. So the first time it crosses, it goes negative to positive. That's a minimum. Here on this side, it goes positive to negative. That's a maximum. And that's it. So this last time right here goes negative to positive. So where's the only time in the graph where the derivative goes from positive to negative? That's a maximum, and it happens one time. And then what value is that? If I want to know what that value is with the graph, because I actually have to find where the value is. If I turn the page, actually, there's only one option that says 1 only. So if there wasn't that, so the answer is E, because that's the only one that has one situation where it crosses over. But if I needed to know the value, press menu. We're going to analyze the graph, and we're going to find the 0. So press 1, and then see this vertical dotted line. Move it to the left, and then press down. Move it to the right. And as it's going to the right, as it covers the 0, you'll actually see the answer. You can actually press down your hand on the number and move it around and open it up again to actually see it better. But you can see it's 0.542. That's where it crosses from positive to negative, and there's your answer. So the answer to number 32 is E. All right, let's look at number 33. The function f is given by that, and it has a relative minimum when x equals what? Now, this is not a calculator question, so we're going to have to do some work on 33. So how do we find a minimum? So the answer is we take the derivative, and we're going to do the power rule. So 2/3 times 9. Basically, you can go 18 divided by 3. That's 6. And then when you subtract 1, 2 take away 3, that's negative 1/3. The derivative of 3x is 3, and the derivative of negative 6 is 0. Next, we're going to make it equal to 0 and solve it. So it might be helpful to write this as a fraction. That is the cube root of x in the denominator. So that may be helpful, it may not be helpful. And then I'm just going to do some algebra from there. So I subtracted 3. I'm going to multiply both sides by the cube root of x. And then I'm going to divide by negative 3. And then the last step is I'm going to cube both sides. Now, negative 2 cubed is negative 8. So that's the one number I'm looking at, is negative 8. Now, there is actually another number to look at for the minimum, in that the derivative, if I wrote down the derivative, so if I wrote down the derivative without a negative exponent, this is also the same derivative, just written as a fraction. What we need to remember is it's not just making it equal to 0. The next part also is, are there any values that make it undefined? So if you write it as a fraction, you can clearly see that x cannot equal 0. So if there's a place where the derivative is undefined, and if I look at the actual question at the beginning, that is not a domain restriction. In fact, this has no domain restriction. So 0 is okay for the function, but the derivative, it's undefined at 0. We need to include it in terms of our critical numbers. So we have two critical numbers to look at. So we have negative 8 and we have 0 to look at in terms of that. So negative 8 is making it equal to 0. 0 is what makes it undefined. We need to look at both. Now, I'm going to rewrite the derivative again. So there's the derivative. And so what I'm going to do is I'm going to plug in a number. So if I plug in like negative, something hugely negative, this fraction is going to be too big. It would be a negative, and eventually this would be going to 0 plus 3. this is going to give me a positive answer. So if I plug in negative 1 billion, this is going to be very close to 0. Plus 3, it's going to be a positive answer. If I plug in a number here, let's say I plug in negative 1, the cube root of negative 1 is negative 1. So 6 divided by negative 1 plus 3, that gives me a negative answer. And then if I plug in any positive answer, the answer is positive. And now the question is, where is there a minimum? So the minimum occurs right here. So before 0, it's negative. After 0, it's positive. So it decreases, and then it increases. So at what x value is there a relative minimum? And the answer is right there, and the answer is 0. All right, turn the page. Number 34. All right, in number 34, the figure above shows the graph of the first derivative of the function f at, and then it says f at 0 equals 0. Which of the following could be the functions for f? So before I start doing that, in fact, I'll do it right here. I'm going to draw a number line to understand it better. So it goes from 0 to 4. We can do that. And then from 0 to 2, it's above. So it's increasing. And then from 2 to 3, it's decreasing. And then from 3 to 4, it's increasing again. So I'm looking for a graph that's increasing from 0 to 2. So A is wrong because it's not increasing from 0 to 2. It increases and then decreases. So I already know A is wrong. So do they all increase from 0 to 2? So look at B. From 0 to 1, it increases, but then it decreases. Well, no, it needs to increase all the way from 0 to 2. So B is wrong. Look at C. See if I can pull back just a little bit, but yet be in focus. Notice from 0 to 2, does it increase? And then from 2 to 3, it decreases. And then from 3 to 4, it increases. That's good. If I look at D, it increases, then decreases, then increases as well. So D could be a possibility. So now I need to look at concavity. So if I go back and look at the concavity, when I look at the derivative, I'm looking at increasing and decreasing. So let me do that above right here. So again, from 0 to 4. So this is increasing up to 1. That's concave up. Then it's decreasing to like 2.5. And then it increases to 3.5. And then it decreases after 3.5. So this is telling me concavity. It smiles, then frowns, then smiles, then frowns. So let's see which one smiles, frowns, smiles, frowns. So it says the first one is at 1 and then 2.5. So if I look at 1, it smiles, and then it frowns to about 2.5, and then it smiles to about 3.5, and then it frowns at the end. C matches with concavity. So as it smiles, then frowns, then smiles, then frowns. D does not match with concavity. So you have to look at both increasing and decreasing and concavity and see which one matches. I'd even look at E, but E is wrong because it doesn't increase from 0 to 2. So from 0 to 2, it should be increasing the whole time, and it doesn't. Number 35. The derivative is given. At how many points will the graph have a relative maximum? So to find the relative maximum, the derivative is given here. So how many times? So I'm going to draw a number line. So the numbers I'm looking at are 0, positive 2, and negative 3. Those are the numbers that make, that are zeros of the derivative. So what values for x make the derivative 0? So that would be 0, that would be positive 2, and that would be negative 3. There they are. If I plug in a number, it might even helpful here. In fact, I'm going to give you another technique here. if I ask you what the power term of the derivative is, it would be x to the, so x to the fourth times x times x. That's x to the sixth. Now, why would that be helpful? Because the end behavior for x to the sixth, both ends go up, right? So both ends are going up. At -3, it has an odd multiplicity. It crosses over. At 0, it has an even multiplicity. So it stays the same. And then at +2, it has an odd multiplicity, so it crosses over again. So looking at this, how many points does it have a relative maximum? It has one at -3, and that's it. So negative to negative, no maximum or minimum. And then negative to positive is a minimum. So where is it? Just one spot. And the answer to 35. And if they asked for the answer, it'd be at -3. All right, number 36. The derivative of the function is given for 36. You're allowed to use a calculator. How many points of inflection does the graph of f have on the open interval from -2 to 2? So you're given the derivative of f at x. I think the most helpful thing here is to graph the derivative of the derivative. So you're given the derivative. So let me show you my graph again. And I want to see how many times it crosses over the axes in that interval. If it crosses over, it creates a point of inflection. So I want to click on, escape that. Let's click tab, and then let's erase this. And then we're going to type in, first of all, click the button beside the number 9. So this button here on the right beside the 9, that will give you the derivative button. So press 9 beside the number 9, and then go to the first derivative. So you're already given the first derivative, and you want the second derivative. So all I want is the derivative of that derivative. So I want the derivative of x squared, and then cosine x squared. So it's x squared cosine x squared. Now I'll change the interval after I do that. So there's that. And then I'm going to change the interval. So I'm going to go menu, and then I'm going to go window, and then I'm going to select window settings, and then I want it from -2 to +2. So -2 to +2. I want that window. How many times does the graph cross over when you look at it? So when I look at it, I see 1 here at the beginning. Here, there's 1 here on the left, then 2, then 3, and then 4. Oh, and here 1 on the right. 5 times it crosses over. And it doesn't matter if it goes negative, positive, or positive, negative. Changing from positive to negative or negative, positive is a concavity change, which is a point of inflection. So the answer here is 1, 2, 3, 4, 5. So there's the answer. All right, number 37. The derivative of the function f is increasing for x is less than 0 and decreasing for x is greater than 0. Which of the following could be the graph? So I'm going to draw a number line so I can understand this. At 0, it says if it's less than 0, it's increasing. And at greater than 0, it's decreasing. And so which one could be that graph where it's increasing and then decreasing? Of course, at 0 would create a maximum. So that's what we're looking for. So A is wrong because that's a minimum. B looks like it could be right. Let's look at it. So we want increasing, then decreasing. Oh, I totally read it wrong. Okay, let's go back. So it says the derivative of a function. So this, what I just did, is cool, but it's the derivative that I'm looking at. So this is not that. So if the derivative is increasing, decreasing, this is concave up, this is concave down, and this is a point of inflection. So is it concave up, and then at 0, there's a point of inflection, and then concave down. So A is still wrong, because it's only concave up. B is wrong, because it's only concave down. C is concave down, and then concave up. It's wrong. D so we're looking for concave up and then concave down. So that's concave down. This is also concave down. So C and D are wrong. E is the one I'm looking for. So if I look at E, it's concave up, point of inflection, and then concave down. And that's why it matches. So the correct answer here is E. Question number 38. So the first derivative of the function is given. On which of the following intervals is g decreasing? All right, so this is a calculator question. So if you're given the derivative, what you're looking for is where is it below. So again, I'm going to graph it because I think it's easier to graph to answer these. Again, I'll let my camera try to focus in here. So I need to go back and erase this one from the last question. I'm going to type it in. So it's cosine, it's pi, it's x squared. So cosine pi x squared, we'll do that first, graph it. Now the window we're going to change. So 4 and then 1. And then we want our window to go from negative 0.5 to 1.5. Now we need to know what we're looking for in this one. So there's the window I'm looking at. Where is it decreasing? So you can tell it's decreasing right here where the derivative is negative. It's decreasing when the derivative graph is below. So in what interval is it below? So if I look at this point to that point. So if I just look at it, all right, so let's get that first point. So let's go menu. Let's analyze it, number 6, and let's find the 0 there. So that first 0, move it to the left, press down, move it to the right, and you can see the first interval is 0.707. So there's only one answer that's like that. If I look at the next one in terms of it, the other one is 1.225. So there's my answer. From 0.707 to 1.225, the derivative is below the axes. All right, question number 39. In 39, you can use your calculator again. The first derivative of the function f is defined by that. On what interval is it increasing? All right, so we're going to graph this again. So take out your calculator, we'll graph it. So on which interval is it increasing? So for the derivative, I want to see where it's above and below. So let me do that. Show you the calculator. So again, we're going to press tab. And then we're going to erase. And then I'm going to type it in. So I'm going to go control divide. That's the fraction line. And then x plus 2e to the negative x. Make sure I type it in correctly. X squared plus 0.7. All right, so there it is. And then I want to get a better sense of this graph. So go menu. I don't see where it crosses anywhere. So if I do a window, let's say I do a standard window. So I don't get any sense here that it crosses over anywhere. So if I get a sense of the left end behavior, it's going to infinity on the left. On the right, what I notice is it's getting closer and closer and closer and closer to 0, but it's not crossing it. So if I even ask for, is there any intercepts, we could press and come back here and we could just solve a real basic equation. All right, let's go menu, then algebra, and then solve. And so because I already defined it, I can just go f1 at x equals 0. I just want to see if it even touches it. Like, are there any intercepts to even think it could cross over that I'm not seeing? And then go comma x. So if I take the function equal to 0, yeah, it doesn't know how to do it, right? And so it doesn't give me an answer that's obvious. Like looking at that and looking at the graph, what it does is it's saying it's getting closer and closer to 0, but it won't solve that equation for me because it can't, because it doesn't exist. So the entire graph is above. And if that's true, if the entire graph is above, that means the entire function is always increasing. So the correct answer here, because the entire derivative is above the axes, that means it's always increasing from negative infinity to infinity. All right, number 40. Let f be the function with the derivative given. So I'm given the derivative. Not a calculator question, so we actually have to show a little more work here. On what interval is it decreasing? So to understand it, I need to know where the zeros are. So if I look at the numerator, what makes the numerator 0 is 0. If I look at the denominator, no matter what number I put in, negative, positive, 0, this will always be positive. It's impossible for the denominator to be 0. So the only number I really need to look at is 0. If I plug in a negative number, a negative times a negative is positive. The bottom will always be positive. If I put in a positive value, the numerator will be negative and the denominator will be positive. So that's what I'm looking at. That means the function is increasing up to 0. And then after 0, it's decreasing. So where is it decreasing? From 0 to infinity and beyond. So that answer would be A. That's where it's decreasing. All right, number 41. In number 41, you're given a table of values. It says the derivative of g is given there. It's continuous. You're just given different values. It has exactly 2 zeros. Selected values of g prime are given. If the domain of g is a set of all real numbers, then g is decreasing on which of the following intervals? So I just want you to focus on the y coordinate, or the answer part, the bottom row. It goes positive, positive, 0. Remember, there's only 2 zeros, and then the other one is 0 here. So if I look carefully, the derivative is positive, then it's negative, and then it's positive, only looking at the y values, or the derivative values. And so when it says g is decreasing on which of the following intervals, you can see it's decreasing from negative 2 to positive 2. That's where it's negative. So the answer is A. All right, take a look at number 42. In question number 42, for what values of x does that graph have a point of inflection? So how do you find a point of inflection? Without a calculator, just a real basic question. And so the answer is I need to find the second derivative. So the first derivative is 15x to the fourth, 40x cubed. The second derivative is 4 times 15, that's x cubed. That's 120 x squared. And then I'm going to make it equal to 0. So we take the second derivative equal to 0. I can clearly divide 60 out. I don't want to divide the x out, but I can divide 60 out to simplify this a little more. But I do want to factor out x squared. So I'm looking for what are my two answers? What two values for x make it 0? So it's -2 and 0. So let's do that. So there's the second derivative. If I plug in a negative number, -3, I get a negative times a positive. If I plug in a number like -1, I get a positive times a positive. And if I plug in a number bigger than 0, it's positive. So the only place there's a point of inflection is where the concavity changes. So concave down to concave up. So at -2, we have a point of inflection. That's B. Number 43. So the function f is defined by f at x equals sine x plus cosine x from 0 to 2 pi. What is the x coordinate of the point of inflection? So to find the point of inflection, you need the second derivative. But to find the second derivative, you need to do the first derivative first. The derivative of sine is cosine, and the derivative of cosine is negative sine. Then we do the second derivative. The derivative of cosine is negative sine, and the derivative of sine is cosine, but it was already negative, so it stays negative cosine. We make it equal to 0. We solve it. So I need to understand my unit circle a little bit. I'm going to add cosine x. So I'm trying to figure out what angle do they have the same value, but one's negative and one's positive. So this is going to be a 45-degree angle, because at 45 degrees, they have the same y-coordinate, but one's negative and one's positive. And it says, what is the x-coordinate to go from concave down to concave up in terms of it? So we're looking at pi. So we're looking at quadrant number 2 and quadrant number 4. That sine and cosine, one's negative, one's positive. So that would be 3 pi over 4 and 7 pi over 4. And then I want to know, is the answer positive or negative? So when I'm looking at sine subtract cosine, is that going to give me a positive answer or a negative answer? So from 0, this is 0, this is 2 pi. So if I look here, in terms of it, you'd plug in an angle between 0 and 3 pi over 4. Honestly, pi over 2 is the easiest one. Pi over 2 is at the top of the unit circle, and one of these answers is going to be 0. So cosine is going to be 0. Sine is going to be positive 1, so that's negative 1. So that's a negative answer. Pick pi, that's in between here, that's on the left. If at pi, sine is 0 and cosine is negative 1, so a negative times a negative is positive. It's going to alternate here. So where does it go concave down to concave up? And the answer is here, the point of inflection at 3 pi over 4. A challenging question because you need to know your unit circle and your second derivative rules and all of that. So the answer there is B, 3 pi over 4. Number 44. In question number 44, you're given the first derivative of the function. It says if the derivative of the function h is given there, how many points of inflection does the graph of h have in that interval from 3 to 6? So all you're told is that the h derivative is twice that of this one. Now, by multiplying it times 2, it creates a stretch, right? A vertical stretch. That's all that's happening. So if you take this graph and stretch it times 2, it does not affect how many times it crosses the x-axis. And honestly, when you multiply it times 2, what we're looking for is increasing and decreasing. So right here is a point of inflection, and right here is a point of inflection. So it goes increasing, then decreasing. Do you see this turning point and this turning point? Those are both point of inflections. If you take this times 2, it's still going to be 2 turning points. It's not going to change where the turning points are or how many there are by multiplying the graph times 2. A vertical stretch will make it look skinnier, but it's not going to change how many turning points there are. So anyways, the answer to this is 2, because we have 2 turning points. That's what creates point of inflection. Number 45 is really confusing because there's a graphic surface error. So I need to tell you what 45 looks like. So if you look at 45, what the hey is that, right? For some reason it didn't come through. So I'm going to write it down for you right now. So here's the second derivative. It's x squared, it's x subtract 3, and x subtract 6. That's what, for whatever reason, it didn't write down. You need to write it down. What's the x coordinates of the point of inflections for this graph? So you're already given the second derivative. So I just need to make it equal to 0 and then solve it. So I'm looking at 0, 3, and 6. So I'm going to draw a number line, 0, 3, and 6. I want to know where the signs change. If I plug in a negative number, it's a positive times a negative times a negative. If I plug in positive 1, it's still a negative times a negative times a positive. If I plug in 4, now we have a positive times a negative. And if I plug in 7 or more, it's all positive. So how many times does it change signs? So at 3 and at 6, you can see the concavity changes. And so at 3 and at 6 is where the point of inflections are. 46. Let C be the curve defined by x squared times y equals 4. Which of the following statements is true of curve C at the point 2, 1? So what are some of the questions that they're asking? So they're asking about a relative minimum, relative maximum, decreasing and concave up, or decreasing and concave down. But they're talking about the first derivative and the second derivative. So let's write this down. So it's x squared times y equals 4. So the first thing I'm going to do is take the derivative of that. Now for this one, I'm actually going to do this. I'm going to divide by x squared to get y by itself. That way I don't have to do it implicitly. And if I write it calculus friendly, that's what it would look like. So the first derivative would be negative 8x negative 3. And the second derivative would be positive 24 x to the negative 4. So that's what we're looking at for the first derivative and second derivative. So A says there's a relative minimum because the first derivative equals 0 and the second derivative is greater than or equal to 0. So if I look here, this is negative 8 over the cube root of x. There's no doubt that x can equal 0 here, but here it's undefined, which is fine. That creates a critical value. And so if I plug in a negative number, it's positive. If I plug in a positive answer, it's a negative answer. So at 0, there's a maximum. So I know that this is wrong. A is wrong. B says that there's a maximum. I like that. The second derivative Oh, and it says, what's true at 2, 1? So at 2, 1, there is no maximum and there is no minimum. So I had to know and make sure I read that we're specifically looking at 2, 1, what's happening. So when I solved it the way I did, I only have to look at the x value, which is 2. So if I plug in 2, for x, it's decreasing. And if I plug in positive 2 here, it's concave up. Decreasing, concave up. So the answer is C. And it's actually easier to do it that way than to do it implicitly. So if it's easy to solve for y, make sure you know. In this case, I didn't need both the x and y coordinate. Just the x coordinate, plug it in. So if you plugged in 2 for x, it's decreasing because it's a negative answer. Plug in 2 for x. This is a positive answer, so it's concave up. Number 47. We're not going to be quite as lucky here. Let's see. So for 47, it says, consider the curve x squared subtract y squared over 5 equals 1. It's known that the first derivative is given and the second derivative is given. Which of the following statements is true about the curve in quadrant number 4? So in quadrant 4, x is positive and y is negative. So if that's true, then we know in quadrant 4 that it's decreasing. Because a positive divided by a negative is decreasing. Here, all I need is the y coordinate. So if I plug in the y coordinate, it's negative. But there's a negative in front. So a negative times a negative makes the second one positive, which means it's concave up. So we're looking for decreasing and concave up. So let's see. The curve is concave up because the first derivative is equal to greater. Nope. So concave up has to be the second derivative. Same thing with B. Concave down because of the first derivative is wrong. The curve is concave up because the second derivative is greater than 0. That one I agree with. The curve is concave down because the second derivative is less than 0. It is not. So the answer is C. 47. We just did. 48. Which of the following functions of x is guaranteed by the extreme value theorem to have an absolute maximum from 0 to 2 pi? So in order for there to be an extreme value, it has to be continuous from 0 to 2 pi. That's what they're looking for. Is there a value between 0 and 2 pi that would not make it continuous? So for instance, if I look at the first one, can sine x equal -1 in that interval? Because if sine x can equal -1, that means it's not continuous there. And the answer is yes. That's at the bottom of the unit circle. I'm looking for continuity. How about here? X squared plus pi. Is there any value here that would make this undefined at all? I don't think of any. What would make this one undefined? So if I look here, pi would make it undefined. That's in my interval? And then D, again, pi would make it undefined. So the only one that's continuous, that guarantees a maximum value somewhere because it's continuous, is B. And that's the answer. Number 49. In number 49, you're given an equation and asked to find the derivative of that. And what we need to do, I think, well, let's do it this way. I was thinking of multiplying everything times 5 or not. I got to be able to do different rules here to make this work. I think it's going to be easier if I multiply everything times y. I'm going to try that. That way I don't have to do the quotient rule, and I think it's going to be easier to do it this way. So I multiplied everything times y to begin with, so I don't have to use the quotient rule. That make it more complicated. And now I just have to do the product rule. So the first times the derivative of the second, and then we need a y prime, plus the second times the derivative of the first, which is 1, the derivative of x squared is 2x, and the derivative of 5y is 5 with a y prime. Then I'm going to subtract 5y prime, and I'm going to subtract y cubed. I'm going to subtract 2x. I'm just going to rearrange it. And then I'm going to factor out a y prime and do some algebra to get y prime by itself. And then I'm going to look for the answer that matches. And if I didn't find one that exactly matches, I can change the negatives to positives and the positives to negatives. So the correct answer sure I did it right. The first times the derivative of the second plus the second times the derivative of the first, 2x, 5y prime. I don't see the answer that's matching it. So that would be the answer that I have. So the one that would stick out that I'm looking for, y cubed and 2x. See, can I take one of these answers and have them match? So I see y cubed and 2x. I see 2y minus 5. So I multiplied everything times y to try to make it easier. All right. So let me try it this way. I think I failed you. So let's try again, because I don't see an answer that matches. So instead of that shortcut, it became a long way and not a shortcut. So let's try it again from the beginning, because I don't see an answer that matches. The first part is the same. So it's the first times the derivative of the second. And it needs a y prime plus the second times the derivative of the first, which is just 1. This is going to require the quotient rule. So that's the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared, and that's equal to 0. So that's what I was trying to save you from, but I'm not matching it in terms of what it needs to be. If it has a y prime, well, that needs to be on one side. So what would be a smart move here? We have 2xy y prime. Here, we have a y squared. Here, this y squared belongs to both, so y divides into y squared to just make it 2x over y. And then the second one would be negative x squared over y squared, y prime equals 0. I just want to be able to take the y primes and factor out a y prime from each one. So I'm going to subtract y squared and subtract 2x over y. So I'm just rearranging the equation, and I'm factoring out y prime at the same time. So now I can divide. I still have some work to do. So I divided by 2x, y, subtract x squared over y squared. I'm going to multiply everything times y squared. Everything. That will get rid of the fractions within fractions. So if I multiply everything times y squared, I get negative y cubed minus 2x. Am I going to get the same answer? Multiply everything times y squared. Oh, wait a second. This is y squared. This is where I make a mistake. So I'm subtracting y squared. So this is y squared. So if I multiply it by y squared, this is now y to the fourth and 2xy. This is now 2x y cubed minus x squared. So I just multiplied everything times y squared. So I don't have fractions within fractions. So this is to the fourth. Notice the numerator, I can factor out a negative y, and I have y cubed plus 2x. The denominator, I can factor out an x, and I get 2y cubed minus x. So now it's going to match. So that was a toughie. So that matches with B. And I tried to do a shortcut and I failed. That's okay. Here we go. Number 50. Which of the following functions of x is guaranteed by the extreme value function? That means there is continuous from 0 to 4. And that means there's an extreme value. There's some maximum value guaranteed from 0 to 4 if it's continuous. No discontinuity. So from 0 to 4, which one of these are continuous? There's definitely an asymptote there at pi over 2 and beyond. So that's between 0 and 4. If I look at B, there is nothing. So the domain restriction for inverse tangent is all real numbers. Every number works for inverse tangent. So that's a continuous function. This one, if you factor it, there's a discontinuity. This is positive 5 and negative 4. So there's a discontinuity at positive 4, which is included because of the brackets. And here is 0. E to the 0 is 1, take away 1, discontinuity. So the only continuous function from 0 to 4 is B, inverse tangent, has no restrictions, and it guarantees a maximum value in that range, or that domain restriction. 51. In question number 51, you're given a function. At what values do you have a relative maximum? So to find a relative maximum, you take the derivative. So the derivative of this is going to be the product rule. The first times the derivative of the second, that's 2x plus 2, plus the second times the derivative of the first, which is e to the negative x, but it needs the hook negative 1. And then I make it equal to 0. There's nothing that makes it undefined, so I just make it equal to 0. I'm going to factor out e to the negative x, and I'm left with 2x plus 2 plus x squared plus 2x, but that's all times negative 1. So I got to make sure I'm careful about that negative 1. So I'm just going to focus inside here. E to the negative x can never be 0. So just this second part I'm going to focus in on. So that's 2x plus 2. That's negative x squared and negative 2x. And I want to solve that. So I'm going to add x squared, negative 2x and positive 2x cross out. I'm going to subtract 2 as well. And so if I solve it, I'm going to add 2 back. I didn't need to do that, right? I made it equal to 0, but there's no linear term, so there's no sense factoring it. Take the square root, and the answer is positive and negative root 2. And it says, where is there a maximum? So e to the negative x is always positive. If I simplify this of what's inside again, it's 2 minus x squared. So we have e to the negative 2x And this is what I have, 2 minus x squared, if I simplify it. If I plug in a really big negative number, negative 1 billion, this answer is going to be negative. If I plug in 0, the answer is positive. If I plug in 1 billion, if I plug in positive 4, this answer is always positive. This is negative. And then the question is, where is there a maximum? So if I look at the signs, the maximum is when you go from a positive to a negative. That's the maximum at root 2, only there. So the answer is D. Only at root 2 do we have a maximum. That's where the derivative changes from positive to negative. Number 52. You're given a derivative. Which of the following statements is true about it? And it says, is there a relative minimum and one relative maximum and so on? So we're going to graph it because we're allowed to graph it. Let me focus in here. Press tab, and then I'm going to erase what I have before. And then I'm going to put it in. So it is x cubed subtract 3x plus 2. And then if I look here, this is the derivative. It goes from negative to positive. So there's a minimum, negative to positive. It never crosses the other way. It only touches. So there's a point of inflection there, but there's no relative nothing because it stays positive. It touches and stays above. So we only have one relative minimum, and that's it by looking at the graph. That answer is B. One minimum, no maximum. Number 53. And it says selected values of a differentiable function So selected values of a differentiable function are given. What is the fewest possible number of values of c in the interval from 1 to 9 for which the mean value theorem guarantees the derivative at c is equal to 6? So the mean value theorem has to do with IROC equaling AROC. That's what we're talking about. The derivative compared to the algebra version of slope. So from 1 to 9, I can tell you AROC is this. F at 9 subtract F at 1, 9 take away 1. There's the slope formula for AROC. So that's 42 take away 0. And then 9 take away 1. All right, so I don't want it all the way from 9 to 1. But we're still understanding this. We're looking for that. We want to know when that's equal to 6. So the derivative is equal to 6. When I apply this, where do I get the answer also 6? So if I look here, if I go 18 take away 6, that's 12, and 5 take away 3, that's 2. That gives me this from here to here. That is the slope of 6, and that works. Where else could that happen? So if I go 42 take away 18, and 9 take away 5, I'm looking for a slope that gives me the answer 6. So 42 take away 18, that's 24 divided by 4. So those are the two places in the table of values. So from here to here, the slope is 6. And from here to here, the slope is 6. Those are the two places that are possible. So the answer to 53 is 2. Those are the two spots where you can get the answer 6. 54. In 54, it says you're given the graph of G. And when you look at it graphically, the mean value theorem, look at the slope of the line from the beginning to the end. Look at that whole slope, that line right there. How many lines are parallel to that? That's what we're looking for. So based on the graph, what are the values of x that satisfy the mean value theorem? So where is the tangent line parallel to the A rock between 2 points? So I want you to notice here and here, they're parallel to the beginning and the end, the slope using the end points. So which tangent lines are parallel to that? That's A rock is the middle. I rock are the ends where there's tangent. So I rock uses 1 point. A rock uses 2 points. They're parallel, which means they're equal. So the answer to question number 54 is C at x is 1 and x5. So x1 and x5, they're parallel. All right, 55. In 55, you're given a rectangle, and it says about minimum or maximum area of that rectangle if you look at the answer choices. So what's an equation for the area of this rectangle? It's length times width. So the length is 2x's, and the height of it, or the width, is the square root of 4 minus x squared. So there's the formula. Length times width. And I wrote it calculus friendly to be helpful. I'm going to take the derivative of this. So that's the first times the derivative of the second. And it needs the hook negative 2x plus the second times the derivative of the first, which is just 2. So I need to do the product rule with the hook involved. So there it is. And I want to know where is it equal to 0, or where there be values that could make it undefined in terms of the derivative. So let me rearrange this. So just know that 2 times a half just leaves me with x over the square root of 4 minus x squared. Oh, we still have a negative 2x at the end. So we have negative 2x times x. That's negative 2x squared if I simplify it. The second one, I have 2 times the square root of 4 minus x squared. And now I want to solve this. I'm going to add 2x squared over the square root of 4 minus x squared. I'm going to cross multiply. Know that square root times square root undoes each other, so it's just 4 minus x squared. You can divide out the 2. Add x squared to the other side. That's 2x squared is equal to 4. Divide by 2. And then you have the answer root 2. Now we don't need the answer negative root 2 because we're just looking at the positive x value on the graph. So we're looking at root 2. And then we want to know, does root 2 give me a maximum area, or does it give me a minimum area in terms of it? Now, if I plug root 2 in here, we still have 2x's. So the area here is root 2 and root 2. That's 2 root 2 is 1. And then if I plug root 2 in here, root 2 squared is 2. 4 take away 2 gives me root 2. So first of all, it's 2 root 2 by root 2. So A and B are wrong because they have the wrong dimensions. Is it a minimum area or is it a maximum area? That's the next part we can look at. So then we have to look at the derivative that I came up with, which is here. If I plug in a number like positive 1, is the answer positive or negative? So if I plug in positive 1, what's the answer that you would get? And if I plug in a number like, whatever, a big number, it has a radius of 2, so I have to plug in a number that doesn't go beyond that. So between root 2 and 2, like root 3 or something, know that the derivative goes from positive to negative, that it is a maximum area with those dimensions. Really, this should have been a calculator question, honestly. Number 56. In number 56, consider all the lines in the xy plane that pass through the origin and a point xy on the graph. And it gives you y equals x squared subtract x plus 16. That's the curve. The figure above shows one such line through the graph. Which of the following statements is true? So the slope of the line for this one would just be the y value over the x. That's what slope is. Y over x. We're going to take that slope and understand the y value. So slope is the y's over the x's. So I need a formula for slope with one variable. So y is x squared subtract x plus 16 over x. So that's what y equals. So that's a secondary equation. I plug it into the slope. I'm going to simplify that. So x squared over x is x. That's negative 1. And then that's 16x to the negative 1. So it's a monomial, and I simplify each one to get there. And then I'm going to take the derivative. That's 1. That's 0. That's negative 16. X to the negative 2. And then I'm going to make it equal to 0. So I'm going to add 16, and it'll be over x squared. Cross multiply. Square root it. And because we're looking at the first quadrant, it's only positive 4. I also need to look at the n values, which are 1 through 8, and think which one will give me the minimum slope. So I'm going to do a table of values. So I'm going to use 1, 4, and 8, and I want to know which one gives me the smallest slope. So if I plug in 1, I get 1 take away 1, I get 16 over 1, that's just 16. If I plug in 4, that's 16 plus 16, that's 32, take away 4. That's 28 divided by 4, that's 7. And then if I plug in 8, that's 64. And 8 and 16, that's 8. So 64 and 8, 72 divided by 8, that's 9. So which value gives me the smallest slope? And the answer is at 4, and the slope is 7. So the line with the minimum slope that passes through that is at x equals 4. It's this answer right here. So at x equals 4, you have a minimum slope. And there's the work involved with it. All right, you did great. We're almost done. Mr. G Math over and out. There'll be another video that completes it all. All right. I'm really proud of you for doing your work.